I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are discussing equivalent algebraic expressions. We are going to factor fully algebraic expressions and they will be equivalent algebraic expressions. Set 1 of factor fully if possible is right there before you. We have 12 questions. We also have set 2, which involves further factoring techniques. Let's first focus on the very first set, which is these 12 questions. You can always pause the video, answer them, and then look into my suggestions. We'll learn many different factoring techniques. In fact, we'll apply many different factoring techniques to master them so that we could move on with higher level of mathematics. From polynomials, we'll move to rational functions and then to calculus. Let us see how do we factor them one by one. The first set has difference of squares kind of thing or common difference properties. As you can see, question number 1 is ax cubed minus bx squared. Now, what is common between these? Well, x squared is common, so you factor this out. And you're left with dividing ax cubed by x squared, we get ax, right? And bx squared by x squared, we get b. So writing this difference as product is factoring process. So it could be sum or difference. When written in product form is factoring. You can also check your result. If you apply the distributive property, you get back from where you started, and therefore these are equivalent algebraic expressions. So I think the concept is absolutely clear, and now let's continue. The next one here is 3ab to the power of 5. Let me rewrite this with 3ab to the power of 5 minus 9a square b. First, look at the numbers 3 and 9. What is common between them? 3 is common, correct? And now begin to check the variables. A and a square, a is common, and b to the power of 5 and b is common, correct? Dividing first by 3ab, we get b to the power of 4 minus 9 divided by 3 is 3, and then we have a, right? So that is how we will get. So exponents, as you know, when you divide, the difference of power is taken care of, right? So in exponents, if I have a to the power of m divided by a to the power of n, it is a to the power of m minus n, right? So the difference b to the power of 5 and b to the power of 1 gave us b to the power of 4. Perfect. The next one here is x squared minus 1. So x squared minus 1 is called difference of squares because 1 could be treated as 1 square, right? So it can be written as product of sum and difference, right? So that is how we could write this product of sum and difference. So remember this, that difference of square is equal to product of sum and difference. Perfect. So that is how we begin with this factoring exercise. Let's now look into more questions. So now we have x squared minus x minus 12. Now here we are going to use another strategy which is called product and sum. So we're looking for two numbers whose product, let's say p times q, is minus 12 and this sum p plus q is minus 1. So 12 is the product of coefficients of a and c, right? And now we have to find these two numbers. Well, the numbers could be what? Now in this particular case, if I take 4 and 3, we get the magic numbers. But since negative is more, we have minus 4 and plus 3. When you add them, you do get minus 1. And therefore, I could write this as x minus 4 times x plus 3. So we use the product and sum method to factor this. The question here, we have two of them. We have 18x squared minus 25x minus 3. And the other one here is x squared plus 4. Well, let me talk about x squared plus 4 first, right? X squared plus 4 is never 0, right? So it does not have an x-intercept. If you graph this, what will you get? Well, you are going to get a graph which is going to open up, minimum value being 4, right? So you see, this cannot be factored, right? So x squared plus 4 cannot be factored. So it is important to remember that all trinomials or binomials cannot be factored, right? So we are considering trinomials and binomials. For that matter, polynomials, all cannot be factored, right? So we are looking for the integer factors basically, right? So it is not a factorable thing. We are looking for real zeros basically. Okay, let's continue with the next example. Question 5, 18x squared minus 25x minus 3. Now to factor this, we are looking for product and sum. The product of two numbers should be equal to 18 times minus 3, right? That should be the product. And what should be the sum? Well, minus 25, right? Now, when the big numbers are involved, at that stage, what we do is we try to look into more factors, correct? We know the product is negative. For 3, well, there's only one combination, 3 and 1. But for 18, we could write 18 as 2 times 3, 6, 6 times 3, 18, right? So that could give us all the factors of our interest. Now to get 25 with a negative sign, you clearly see that these three 3's when multiplied gives you 27 and 2 take away will give us 25. So that becomes the strategy to factor. So we are going to split this 25 into a combination of 27 and 2, right? So we'll rewrite this as 18x squared minus 25. So minus will be a greater number. So minus 27 x, and then we have got 2x plus 2x minus 3. You understand? So that is equivalent algebraic expression, right? Minus 25x is written as minus 27x plus 2x. Now, in the first two, we could group factor, right? So we could group factor 9x. So I'm taking 9x common here, giving us 2x minus 3. We already have 2x minus 3 as the other two terms. Now 2x minus 3 will be a common factor. We get 9x plus 1 as the other factor. So we have now factored the given expression, right? So all the coefficients of x are integers. Do you see that? So that is why we are saying while doing factoring, we are looking for integer numbers, right? Question 7, minus 7x squared plus 9x minus 2. So let's rewrite the question, which is minus 7x squared plus 9x minus 2. Now, whenever you find negative in the very first thing, I like you to factor this first, right? So we get here 7x squared minus 9x plus 2. All the signs will change, right? And now we'll look for product and sum. We're looking for two numbers whose product is minus 9 now, and the sum is equal to, product is 7 times 2, which is 14, and the sum is minus 9, correct? So the two numbers which could give you 14 and 9, these two numbers are definitely 7 and 2. Both negative will give us the result, right? So we get minus, and we could now rewrite this as 7x squared minus 7x minus 2x plus 2. So we can factor 7x from the first two terms, getting us x minus 1, and here factoring 2 will give us x minus 1. And now minus is already outside, x minus 1 is factored, and we get 7x minus 2 as the other factor. Do you see all this? Now think like this. You should always get these as the same terms, otherwise you cannot factor. So if you do not get them as the same terms, that means you need to check your result, okay? Let's continue with question number 8 now, which is 10x squared plus 27x minus 28. So now we are again looking for product of a and c, which is 10 times, and negative I'm writing this time before, 28, right? And we are looking for sum of these two numbers as equal to 27. So how can we get these numbers? So strategy is simple. Just write 10 as 5 times 2 and 27 as 7 times 4. 4 can be written as 2 times 2. You get the idea. So break them into their prime factors. Now we are looking for a combination which will give us as the sum 27, correct? 7 times 5 is 35. Do you see that? 7 times 5 is 35, and we are left with 8. That helps, right? So we have the two 35 and 8. Since we want positive, 8 is going to be negative, 35 positive. So we can write this as 10x squared plus 35x minus 8x minus 28. Now in the first two, you can see 5x is common. So we get 2x plus 7 minus. Here also we should get 2x plus 7, right? So 4 is a good number, right? And it goes into both. So we get 2x plus 7. That minus and minus becomes positive. So we do get 2x plus 7 as a common factor and 5x minus 4 as the other factor. Is that clear to you? Do you see the strategy? So we are applying this strategy of product and sum successfully. Now here we have question number 9, which is minus x squared y squared minus 49. You can now pause the video and start factoring them, right? Not a difficult process. So in this question, we have minus x squared y squared and then minus 49. 49 is 7 squared. Well, let's factor out minus first. So when you factor out minus, we get x squared y squared plus 49, right? Now since it is 49 and square is always positive, we cannot get 0, right? So this is it, and further it cannot be factored. So this is the fully factored form. Perfect. Question 10. Now in this question, we have x to the power of 4 minus 16. Now look here, x to the power of 4 minus 16. 16 is 4 square, right? So you could write this as x square whole square, that is power 4, and this you could write as 4 square. So that means I could now factor with difference of squares. So I could write this as x square plus 4 times x square minus 4. Now x square minus 4 can be further factored. So remember to factor it completely. So it can be written as x plus 2 times x minus 2. That is the fully factored form of the given expression. Here is question number 11. Now in question number 11, we have x to the power of 6 this time. So x to the power of 6 minus 1 can be written as x cubed whole square, right? Minus 1, right? So which could be written as x cubed plus 1. So difference of squares we are applying, and we have x cubed minus 1. Now both of them can be factored. So I want to give you the formula for sum and difference of cubes. How do we factor them? So if it is a cube minus b cube, it can be factored as a minus b times a square plus ab plus b square. And if it is a cube plus b cube, then we have a plus b times a square minus ab plus b square, right? So we are going to use this formula to factor it further. So we get here x plus 1 times x squared plus x1 is 1, x and then plus 1, correct? And x cubed minus 1 can be written as x minus 1 times x squared plus x plus 1. Do you see that? So that is how we are going to factor the given expression, right? So this should be minus, sorry. Correct? So that is how we are going to factor a cube plus b cube formula, right? This is negative here, right? You see, one side is positive, the other is negative. So that is how you can remember this, and I hope that helps, right? Try to remember the formula, get this. Next question here, question number 2, is also the last question. We are given a times x minus 3 plus 3 times 3 minus x. You could rewrite this, right? So we could write this as a times x minus 3 minus, if I put here, then we could write this as x minus 3. You can flip it, right? Taking minus common. Perfect. Now x minus 3 is a common factor and we get a minus 1 as the result. So that is how we are going to factor the last question. So I hope now the concept is absolutely clear. So these are the factoring techniques which you have mastered. Then you can go ahead and do the set 2, which we'll discuss in another video. I hope you understand and appreciate what we have done in this particular case to factor set 1 of questions, where we learn many techniques. Common group factoring we started with, difference of squares and difference of cubes also we did. We did trinomials whose coefficient is positive, 1 whose coefficient is negative, or we have a polynomial which is a trinomial in this case where we have a coefficient which is greater than 1, right? We do have factors where just taking negative could give us a common factor. So these are very common examples. Mastering them helps us to move forward. I hope it makes sense. Feel free to write a comment, share your views. In case you like and subscribe to my videos, it will be great. You can always contact me on this given address. Thanks for your time and all the best.